when you're dissolving ionic compounds in water, the equilibrium, the K value, you call it the solubility product constant. It gets called KSP. When you write equations for ionic compounds dissolving in water, if it's dissolving, it started off as the solid and the ions form on the right. And your equations need to be written that way. When you're writing equations for the dissociation of ionic compounds, the solid is always on the left and the ions are always on the right. And what you're doing here is, let's say, for example, I told you to write the KSP expression for silver chloride. Silver chloride is AgCl. The solid is on the left. You have your reversible arrow and you form your ions on the right. And then you balance it as you need to. And then your KSP, your expression, is just your regular equilibrium expression. Your solids don't get included because we've already said pure solids and pure liquids are assumed to have constant concentration. So they don't get included. The concentrations don't get tracked in your equilibrium expression. So let's say, for example, I gave you another one and I gave you barium nitrate, copper carbonate, and lead chloride. Barium is Ba2+, and what's your nitrate ion? NO3-. Your crisscross method, move this over, move that over, ignoring your charges. So you get left with BaNO3 2 solid on the left, and then your charges, your ions reform on the right. So Ba2+ Aq plus NO3- Aq, and then to balance your charges or to balance your equation generally, you have a 2 here. What's the KSP expression for this ionic compound? Ba2+
times by NO3-.
copper 2 carbonate. What does the equation look like?
CuCO3S and then Cu2 plus Aq plus CO3 2 minus Aq. KSP is Cu2 plus and then CO3 2 minus.
Lead chloride.
PbCl2 solid, then the reverse reaction. It was Pb plus aqueous plus Cl2 and then the minus at the top.
Don't break it up into Pb and Cl2 down the bottom. Think about just the product that forms on the right and then balance it out afterwards. So it's not Cl2 here. Think about just what the ion would be. Cl forms a Cl- ion, Aq, and then Pb, this would be your 2+. And then how would you balance it out now? You only need a 2 in front of the Cl-. What would the KSP expression be now?
Pb2 plus in bracket and then times by Cl minus squared.
Magnesium hydroxide.
MgOH2 solid, and then Mg2 plus OH minus.
What am I missing?
The states aqueous.
What do I need to do to balance the OH?
2.
Okay, what's my KSP?
Mg2 plus and then OH minus squared.
Calcium sulfate.
CaSO4 solid equals to Ca2 plus aqueous and SO4 2 minus aqueous.
KSP.
the Ca2 and SO4 2.
Iron 2 hydroxide.
FeOH2, and then the double arrows. Fe2 plus 2 OH minus. So it's solid and then 2 aqueous. And then the KSP OH minus squared times by Fe2 plus.